So yeah, I'm going to go through where that little 2x plus y came from. This happens all the time. It actually just happened in geometry class, so if I got people forgetting it in geometry class, certainly they're probably going to forget it by FST because you learned this in Algebra 1. All right, x plus y squared, you remember, is actually x plus y times x plus y. If you like a graphic of this, I could make a square for you. Ooh, I have a really nice square tool, actually. Here's a graphic. I could say, all right, if this length is x, this other length is y. So what I mean here in a second. All right, if this length is x and this is y, here's a picture of x plus y, and I built a square out of x plus y. Think about what that area is like. While I come back over here and FOIL a bit, x times x, y times y, x times, blah, all that stuff. I get x squared plus 2xy plus y squared. Or if you look at the picture, this little square down here, there's your y squared. This little square up here is going to have an area of x squared. Remember, these are lengths down here, and I'm writing in the areas in the inside. Just a second. Sorry about that, just realized that my audio was not on my head, it was on the table. Alright, so now I'm wearing it. Okay, so this little rectangle here is x by y, this length is y down here, so here's an xy area rectangle, and here's another xy area rectangle. All together now, we have x squared plus 2xy plus y squared. Okay, pause that if you need to. Back to the task at hand, we were trying to expand all these things. If you expand x plus y cubed, I did this in the notes, you're going to have an x cubed at one end of that super huge FOIL thing. You're going to have a y cubed at the other end. But in the middle, it turns out what you actually get is going to be 3 x squared y and 3 xy squareds. You can show this kind of like I showed the last one with volumes. Oh, this would be kind of cool. X plus y cubed as a volume. Oh, this is going to take a bit, but it would be neat. I'll pause and draw. I'll come back. All right, here I've made a three-dimensional version of that. Here's your x length. Here's your y length. The length of all the sides of this cube are x plus y. And if I actually sliced this thing up and tried to find the volume of all the little pieces, I'd have a little piece right here. I don't know if you can see it, but this little piece up here in the corner, this would be a little tiny cube actually. And that cube would have a volume of x cubed. Down here in this corner, if you can imagine, extending all these slicer lines. Down here I actually have a box. You can see it. There's a box down here in the corner that has a volume of y cubed. But then I have a whole bunch of other little boxes. Like I have this little rectangular shoebox looking one up here that's y by x by x. That shape is it's x by x by y. That's a x squared y block. I have some of those. I also have this larger block that's a square on a different side. It's y by y on this side, and it's a depth of x. That's an xy squared. So if you imagine cutting all these blocks up, here's the shoeboxy kind of ones. I have one here, I have one here, and one here, and that's it. I have 3 of those. The xy squareds are these big, like, oh, I don't know. They're sort of square, but they're thinner, like pizza box kind of aspect. There's one here, and there's one back here in the corner in the bottom. There's 3 of those. So I actually have 3 of those of each type, and I have a big y cubed in one corner, and I have a big x cubed in another corner. After this, I'm out of dimensions to draw in, so I can't really show you why that works out. But I could show you that x plus y cubed is what it is, because I could show you that x plus y cubed is the same as x plus y times x plus y squared. This is x plus y cubed. This is more like what I do in the notes. And here you just have to take, well, that's the same as x plus y times this monster, do a whole bunch of foiling stuff, and you get the same thing as what I was talking about before. You get this. Let's do one more, and I'm not going to show you why. I'm just going to say, well, now you can tell it's not exactly predictable, but there is a pattern. This first one is x to the 4th. This y one is y to the 4th. The terms in between are going to go, they're going to cycle through like this little Robin Hood thing here. I have all x's on one end and all y's on the other end, and the exponents are going to kind of steal from one and give to the other as we go down the line. So I'll move from x 4th to x to the 3rd y to x squared y squared. See what I mean? I'm going to take one from the x's and give it to the y's each time. Do that one more time. X y cubed those are sort of the variable terms. But the coefficients, if you haven't noticed, there's a whole lot of ones on the end. The middle gets a little bit interesting. This one's going to be 4. Of course, this is plus, so everything's plus. This one's going to be 6. See what I'm looking at here? This is going to be 6. See what I'm looking at here? This is going to be 4. And this is just y to the fourth. Okay, so if you haven't noticed yet, Pascal's triangle is all in here. Let's look back at the triangle. Okay, so here are those numbers. This one here is the one I just got to, 14641. That's a plus b, or x plus y to the fourth power, is 1 times the first thing to the fourth, plus 4 times something cubed something else, plus 6 something squared, plus 4 something cubed, and 1 plus 1 the other thing cubed on the end. These are, in other words, these are the coefficients that go in the middle of these. This coefficient, of course, is really 1, right? So we have all the 1s on the outside, then it goes to, you see the 3's here, 4, 6, 4. If I was going to do x plus y to the fifth power, that would be x plus y to the fifth would be x to the fifth plus 5x y to the fourth plus 10x squared y cubed plus 10x cubed y squared plus 5 where am I at now? X y to the fourth plus 1 y to the fifth. And that pattern will continue. So if I have to do some random one, and I don't have access to this triangle, I can always find the row I need by using combinations. So if I had to find, let's go to a new page because I'm kind of out of room on the left edge of that thing there. If I had to find x plus y to the 17th power, now that's crazy, I'll just take the combinations. I know the first, well, I know the first thing is going to be 1, right? The first one's going to be x to the 17th plus a whole bunch of nasty math, and then the last thing is going to be plus y to the 17th. And in the middle, the exponents are going to cycle through, right? So the next one's going to be some number of x y to the 16th plus some number of, you notice this pattern yet, x squared y to the 15th. You notice these exponents always add to 17 all the way down in this whole expansion. That's just the way it works out. Plus, and there's a whole bunch more. And then the last one is going to be, we're almost at the y to the 17th, be y to the 16th with one x sticking there. The one before that would be y to the 15th with 2 x's on it, that kind of stuff. Anyway, I could figure out what that number is supposed to be. That number is 17C, this would be 0, 1, 2. 17C2. This one would be, right there, if I really needed to know that one, it would be 17, well, this is 17, choose 17, 17, choose 16, 17, choose 15, would be what that would be. Ironically enough, I picked one that was 2 from the end on that way and 2 from the end on that way. These things actually happen to be equal. 17C2 is going to equal 17C5. I can do that in my calculator. 17C2, which is really, oh, it's not doing the calculator, it's only 2. Let's do it for real with our hands. 17, whoa, that's a weird little fraction bar. 17P2 divided by 2 factorial. 17P2 is just 17 times 16. And 2 factorial is 2 times 1. This is all 17 times 8. Okay, now I do need a calculator. 17 times 8, I get 136. Okay, so that little coefficient there is 136. Now to actually expand this whole thing and figure that all out, that's a disaster. What you're going to have to do, like on the questions in the do now for today, it's not going to be as simple as x times y. It might be more interesting, like 4a plus 3b to the, let's say 5th power, because that's a little beyond what we just did. Okay, well, that's normally going to be, well, I guess you don't have to say normally. It is going, I'm going to go to the next line. This is not going to have enough room. 4a, I'm actually going to be taking to the 5th power on one end. And on the other end, it's going to be 3b to the 5th. I know that. But in between, I'm going to have one of each of those things in some capacity. It's going to be 4a. Whoops, I left off space for my coefficient here. Plus some number of 4a 3b to the 4th. And see, now I've got a little bit of a mess here because I've got all that other stuff in here. But it's not impossible, and it's a lot better than actually trying to write this out and FOIL it 5 different times, because after the first one, it gets really messy. All right, the number that goes right here then is 5 choose 1, which is not too hard to figure out. This is 5, choose 0, which is 1. This is 5, choose 1, which of course is 5. How many ways are there to choose one thing out of 5? Great, no problem. It might be easy to go from both ends at the same time. I don't know. Let's try that. This end is not going to be, is going to be 3b to the. Oh wait, I did this one in the wrong place. I was getting ahead of myself. I was Robin Hooding the wrong direction. Turns out the term I had is going to be in the sequence, or in the polynomial. I just put it in the wrong place. The 3b to the 4th is at this end. 4a. And yeah, it turns out this is going to have to be 5 again. The number here is 5. This is because that is what 5c4 is. That's how many ways are there to choose 4 things out of 5 things? Well, there's 5 ways, because there's 5 different ways you can exclude one of them. I still might not even have enough room in here. All right, now it's getting tricky. It's 5c2 that goes in that spot. How many ways are there to choose 2 things out of 5? Oh, I guess I could go calculator on that. 5. How many ways are there to pick 2 things? There happen to be 10. Okay. So it's going to be 10, and then I got to cycle this exponent around. 4b cubed, 3b squared. I like coming from both ends, so I'll go back one from this one. This will be 3b cubed, and actually I think this will be the last one, right? 3b cubed, 4a squared. And now I'm actually neighbors with this one. Great. And I also know that's going to be 10. 5c2 and 5c3 are the same. Picking 2 things is like excluding 3, or picking 3 things is like excluding 2, so it's the same. So yeah, and if I look at my Pascal's triangle, it's 1, 5, 10, 10, 5, 1 at that point. And the exponents just do this little borrowing from each other until they go from one edge of the scale to the other. Okay, and then if I really wanted to figure out these terms a little more simply, I could say, well, that's 4a to the 5th. I mean, I could simplify each one of these terms. Plus, and really I should multiply all these things, 5 times 4 to the 4th times 3. Oh, yuck. 5 times, all the sort of number parts of this, times 3. That's 3,840. Now, that's not right from Pascal's triangle, but there's more going on here now. 3,840 a to the 4th b's plus, and then I'd go 10 times 4 cubed, etc. I really don't care to do that. However, this 38, oh wait, I didn't do 4a to the 5th correctly. Gosh. Slow down. All right. It's 4a to the 5th, which means I also have to take 4 to the 5th power in my coefficient, which is 1,024. This is actually 1,024. My point of starting this, at least, and not finishing it, is to tell you that now when I do that, this is not going to be symmetrical. This little coefficient on the a to the 5th is not going to be the same as this, because at this end I'm taking 3 to the 5th, which I think is 243. 3 to the 5th power is, yes, 243. This is actually, at the end, it's going to be 243b to the 5th. So it's not quite as tidy and symmetrical as everything else. Anyway, that's what you do if you were going to simplify all that. I'm running into the point where I got to start wrapping it up. I think I've actually talked about most of this stuff actually in the first video. I just did some examples in the second video of the hardest parts. The questions from the beginning you were supposed to answer, or be able to answer at the beginning of your discussion here. Let me get this back in the frame. Yeah, we just did that. This has to do with Pascal's triangle. Think about how those would be arranged in Pascal's triangle and where you would find this one if you knew these two. I actually just told you what those two were. Those two happened to come up in the last example. But remember how Pascal's triangles are arranged and how you can work your way down the thing. If you know this one and this one, you can find the one below it. Because after all, something like 15 plus 6 equals 21, and 21 plus 35 equals 56. Okay, that's great. 3 sections. Congratulations to me for making it. Congratulations to you for watching it. I'll see you in class.